My name is Mark Schifferli. I'm from Fathom Information Design in Boston, and we're looking for designers and developers too. So if you ask me flattering questions that make me look smart at the end of the talk, I'll definitely be interested in talking to you about working at Fathom.
Where'd you get that fabulous sweater?
It was a gift. All right. I think the best way to kind of describe what I hope to do tonight is starting by talking about the Fortune 500. Fortune magazine for the past 55 years has gone and looked at US companies, looked at their companies that publish their revenue publicly. They sort them by the most to the least. They take the top 500, and that's how they come up with their list. So they've been doing this for 55 years. That's like 27,500 revenue numbers for the past 55 years. If you try to look at that, it's too much to read. You can't really make sense of it. What we have here are pairs. We've got the year 1955, and right at the top, right at the edge of what you really can't see, you've got the revenue number for the highest revenue company of 1955. That's in millions, so it's 9,823,000. Or 823 million. Again, too much to read. It's 54 pages of dense numbers like this. You can't really make sense of it. But if you put it in a graphic, you can. You can get some trends, and some pretty meaningful trends. This is the revenue across the x-axis. We have the years. Y-axis is the revenue. And this is adjusted for inflation. You can see that even though it's adjusted for inflation, revenue has been going up for the past 55 years. It's kind of sparser at the top, denser at the bottom. You've got the recession in the 70s. You've got a change in the criteria for Fortune magazines, the companies that they would accept. They widened the criteria to let more companies in, so that raised the competition. The lower end of the spectrum goes up. So that's cool. You get to see this trend. But no one goes to Fortune 500 to see the trends like that. They want to know what's the top company, what's the best. What company, if they're number 100 this year, where were they last year? And you can get all that information, and you can find it in a table. But again, this table's huge. It's too hard. There's too much to read. But you can find the data. But now you've got more numbers and more data points. You've got the years, you've got revenue, you've got profit, and you've got the company name. And you've got the rank. So that comes out to 137,500 numbers. Again, too much to read. But if you put it in an interactive thing, then you've got access to the trends, and you've also got access to the details. And I'd like to show you a quick example. This is a piece that my boss, Ben Fry, put together. And so here it is. Here it is. Not there it is. There it is. So here's what we were just looking at. If we go by revenue, that's the view we just had. And one thing I'd like you to notice is that now we can kind of look at it by rank. And you can't read anything. We'll get there in a minute. But you can also order it by profit. And with the animation, it's very clear. You get to see more than just the revenue trend. You can see the profit trend. Again, x-axis is the years. Revenue is vertically. It's a logarithmic scale. But if we go to the rank, now we want to know who was on top. Well, if I very subtly put my mouse up there, now I get to see all sorts of information that I didn't get to see before. 1955, the top company was General Motors, and that red line now is the trend of where they were for all 55 years. So you can see that they've done really well over the past 55 years, but the last year they kind of started to go down. And then as you go through here, you can see all sorts of trends. It's kind of fun. Over on this side, you look at the earlier part of the Fortune 500. You see all these industries that have kind of tanked, that just aren't as important anymore. And then over here, you've got, it's kind of hard for me to see because I'm looking at the screen. But yeah, Exxon, but also you see Walmart come out of nowhere, which is kind of fun. Let's see. But in general, you can extract all sorts of information. You've got access to every data point. You've got access to the company name. You've got the revenue, the profit, all the numbers that you need to know, and all these crazy trends. Trends that if you were to try to put it in a static visualization, you would have a hairball. If you tried to draw all these trends on one screen or one piece of paper all at once, it would be so dense it would be unreadable. So that's what kind of the value is here with interaction and data visualization. So a quick overview of let's save it for later, actually, if you don't mind, because I'm kind of tight for time. I got a lot to cover. So basically, the way I'd like to take you through this today is kind of a brief review of what data visualization's all about. And it's going to be brief, and I don't pretend to be thorough. I don't, we'll do what we can in the time we have allotted. But a brief look into what it is, why it's important, why it's a useful thing now, how to do it, and some criteria for good ones versus maybe not so good ones. Then looking at similar data sets, I want to do a comparison of some static visualizations versus interactive ones. And then later we'll come back to an example of a really complicated data problem that, for which Fathom built a solution that is, in my mind, pretty cool, but it's my baby, so I would think it's pretty cool. All right, so data visualization. What is it? Essentially the graphic representation of data. Pictures of numbers. People have been doing it for a long time. A very long time. This is from roughly the year 950 of the Common Era. So it's a time series of stars or the planets moving across the night sky. It's roughly a month. Each one of these bars is probably a day. You can see the moon kind of do its monthly cycle. You can see the sun wobble. I don't know what that's all about. I'm not here to talk about the accuracy of the data from a millennia ago. But it's kind of fascinating to think that over 1,000 years ago, people were drawing pictures to make sense of their world and collecting data, collecting numeric data and drawing pictures of it to make sense of it. Not just in Europe, also in China. This is a map from 12th century China, which is amazing for its fidelity. I mean, this is the shape of China. And if you look at the maps that they had in Europe at the same time, it's kind of like, here's the earth, here's heaven, and here's God over all of it, And this is pretty amazing in its cartographic detail. You've got the major rivers, you've got the Yangtze and the Yellow. It's an area of roughly 2,200 miles per side. So broad area. Amazing detail, 800 years ago or more. I'm not going to do the math. You don't want to watch me do the math. It's painful. Here's a bar chart found in the margins of a book written by a bishop in France, which that's from the 14th century. And then 200 years ago, we have William Playfair is doing this multivariate data plot. He's got all sorts of dimensions of data. What you have are the circles represent different countries of Europe. The size of the circle, the area, represents the landmass. The colors, I think, I've read different interpretations of what the colors are, and I haven't been able to fact check. It might mean the different populations that comprise that country. It might mean different revenue. Is that? That's the Russian Empire. Okay, excellent. Thank you. And then you've got, so in addition to the circles, you've got, this is also like the earliest example of a pie chart. And then you've got these bars here, which represent population in millions, and then tax revenue in pounds sterling. And he was making a political point. The slope is not really informative because you've got skinny circles and fat circles, but basically you can see if the line's going down, then people are paying less than £1 in taxes. If the line's going up, like it is here, each person is paying more than £1, paying several pounds in taxes, and he was making a political point. He didn't like how much the taxes were in Britain at the time, so this was part of his argument. Sounds familiar. What's new is the amount of data. People have been doing visualizations or statistical graphics, however you want to call it. They've been doing it for a long time. We're inundated. We have more data to deal with than ever before. IBM is saying that 90% of the data that exists in the world today was generated within the past 2 years. It's we've got more than we've ever had to deal with before. So how do you make sense of it? That we've got how to make sense of it. I like to use visualization, as you can imagine. So why visualization works is your brain's kind of wired to process visual inputs. If you're reading, you have to focus your attention on something. The visual inputs are kind of the things that get your attention. They'll steal your attention away from your reading. They're called pre-attentive variables, is yeah. They're pre-attentive, they grab your attention. Your brain processes this information much more quickly than it can with text. And if you want an example, I want to give you an example. Oh, my mouse. Here it is, perfect. It's on the screen where it needs to be. That's it. No, it's not on the screen where it needs to be. Oh, this is tricky. Let me quit this one. All right. I don't like PowerPoint. Let me just see if I can get this to show up for you, because it's showing up on my screen here.
Close it, drag it over to the other screen, and open it again.
Okay. Thank you. Okay. Nope, it's not coming up that way.
I'm going to change it from 2 screens to 1 screen. There's a button on the function top row
Of
that has 2 boxes on it.
I'm on a Mac. Does that?
Well, you could do it that way too.
I can hope to do that. Wow. Well, rats. Function key. Turn on mirroring. I just saw it. Oh, yes. I can do it. Yes! We're rockin' dockin'. Okay. Thank you for your kind assistance. All right. The task I would assign to you now is to try and find the numbers that are over 90. There are 200 numbers there. You can try to read it, and it would take you a while. And I won't put you through me trying to find about, quickly, 92, 91. You have to read each number, et cetera. Now, if I tell you that you need to look for the ones that have stars next to them, it's a lot easier. Your eye can find those a lot more quickly. Same with size. And color is another one. We break color down into 3 things. There's the hue, so there's the green ones and the blue ones. There's how gray it is versus how saturated, brightness. The position is also something that's going to catch your eye, catch your attention quickly. Orientation, these are rotated. And this one, the texture, kind of comes through. But all these things are visual cues that your brain will process much more quickly than it can process the text. One moment. Now back to my turn off mirroring. Okay. So, oops. So in data visualization, it's going to be powerful, it's going to be effective if you can link the mapping of your data to these visual cues. And I'd like to show you an example that Fathom did last year. It's a poster. It's called Density. We made it to mark the population of the Earth going past 7 billion. And it's obviously a map, and I'm going to zoom in on a detail. The cooler, larger gray circles represent more elbow room per person. The yellow is getting denser. The hottest areas, the reds, that represents the areas of highest population density. In terms of pre-attentive variables, we've got the color and the size of the circles mapped to the population density, and the position obviously shows the amount that represents that data on the map. And it's obvious the position is representing the place, it's a map, but you could actually imagine an alternative version where you didn't have it laid out on the map, and the only thing you'd probably take away from that is how much of the world is densely populated, which would be an interesting thing to do, but very different. This is nice in that it's so immediately intuitive. Once you understand that the big, darker, big, cooler circles are more sparsely populated, you get a feel for the entire world at a glance. And you can see that China is very, very dense in general. Tibet, not so much. 6 of the most populous cities in the world are in China. They're highlighted by these white circles. And then compared to that, our eastern corridor is, it kind of looks roomy. But that's the densest part in the United States. So hopefully that's a good example of how the pre-attentive variables can lead to an immediately intuitive presentation of data. What goes into a good visualization? Subject to much debate. But there are a few things I want to, just a few that I want to point out. It's got to be accurate, it's got to be legible, and a lot of people say it should be dense. One of the reasons to do data visualization is to present lots of data, more data than you can get from other means. So here's an example of an inaccurate visualization. This is heights of some people in my family, and it's basically just a quick little lie. If you've got this bar, and I'm not sure if you can read it in the back there, this little legend here, it's 72 inches. So the tallest person, roughly 6 feet. If you were to look at that and measure the heights of the bars, you would come up with a ratio of 1 to 6 to 12. So the shortest person would be roughly 6 inches high. My wife would be 3 feet high. And my wife's a little taller than that. When we correct it, when we get the values, the proportions of the bars that we represent here, proportionate to the actual heights, it's an honest graphic. It seems silly to point out, but quite frankly, there are lots of infographics and visualizations that get this wrong and can lead to totally misleading conclusions because the representation doesn't map, the data that you pull out of the graphic doesn't map to reality. You also want your visualization to be legible, intuitive. You don't want your users spending time thinking about how to read it. You want them getting the information out of it and thinking about the domain, thinking about the interesting stuff. So this is very intuitive. Well, I hope it is. I mean, it's pretty obvious. You could tell that my daughter's just over 4 feet tall. My wife's just over 5 feet tall. Actually, if I labeled it in feet instead of inches, it'd probably be even more obvious. That's very clear. Legibility isn't the only thing. Sometimes you have to balance that with the detail that you need to provide. In this instance, we kind of go back to that first presentation that was a lie, but we've got the labels clearly, we've got it labeled here. So once you read this, you're not going to think that my daughter's only 6 inches tall. And we've also got this visual cue that says there's more information down here, but we're not concerned with that. And this is, you'll see this kind of thing in stock charts a lot of the time, is the stock price fluctuates between a daily high and a daily low. People want to know just how many, just how much money things changed in that range. You don't have to go all the way down to 0. So you've got to fit the presentation to the data, to the story you're trying to tell. And then you want a dense data graphic. If you've got a lot of data to present, it's good if it does. This is a map pulled from Tufte's visual display of quantitative information, and it shows cancer rates for every county of the United States. And it's a really excellent graphic. It's very clean and at a glance. The darker colors map to higher incidences of cancer. And the demographic it applies to is white women. I think it's ages from 1950 to 1969. So darker colors map to higher cancer rates. You can immediately see that LA was not a great place there was a lot of cancer in LA. I don't want to make any judgments, but there was a lot of cancer for white women in LA in that time period. The Northeast has a bunch too. Huh? It could be, yeah, maybe they did, who knows? But the data says that, that there was more cancer in those areas. And this is excellent. You can immediately get the geographic trend for cancer rates. And there are 3,000 counties in here, and you can detect it at a glance. So what can the interactive aspect do for us? We've kind of reviewed quickly what static visualization, what goes into a static visualization, why you might do it, et cetera. What can we do with interactive? Well, let's go back to this example of the maps. This is actually a different demographic. This is white men cancer rates, 1950 to 1969. But it's from the same set. There are 6 maps in this set, in this book. And you can see it's a different trend. LA isn't quite so bad at this point. The incidences of cancer for white men was not as great as it was for women. Northeast is still a problem. There's kind of a different pattern in the south at the southern part of the Mississippi. But one thing that this graphic can't do for us is provide us with the details. You'll never get the actual numbers written on here. Like how many people live in those counties and how many actually came down with cancer. And you can't see the county names. I used to live in Indiana. I used to live in Monroe County, Indiana. But it's actually been so long, I'm not exactly sure where that is. And so I might be curious to know what the cancer rates are, but I can't find it here. Furthermore, comparisons are very difficult. If you've got 6 of these, finding trying to make a comparison between them becomes really difficult. You're spending a lot of time finding the information. For instance, in Alabama, like for men in this little dark county here, I guess if I do it this way with the mouse, both sides will see it. Like that county in Alabama, it's really dark for, is that Alabama? It's hard to see here. It's really dark, but finding the corresponding county on the women's map, it's going to take a lot of time. I'm spending my mental effort looking for the data as opposed to thinking about the trends, the comparisons, the analysis. And there are 6 of these maps. There are even more. So it gets even harder to do with more data factors. Can we increase the data density? When we look at this map in terms of the pre-attentive variables, we've got the shape and the position and orientation are kind of all taken up by the geographic mapping, but we also have color. We've got hue, we've got color, we've got brightness, texture. Can we use those? Can we overlay those on the other data to get more data per county? And we can, but it becomes harder to read. This presentation has maps the rate. This is a different data set, just so you know. It's a similar problem, different data set. We've got death rates mapped between yellow and red, as a percentage, and the number of people dying in kind of that gray at the top of this legend going down to the yellow at the bottom. So the data's there, it's presented, but and there are some things that you can kind of pull out of it. There's this obvious yellow field that goes from the northeast to the middle of the country and is in northwest, red elsewhere. But it becomes difficult, quite difficult to make sense of it. So we did an app, we released it last year. Actually, most of the work was done before I started with the company, but it's still Fathom, so I want to show it to you. And it's a similar set of problems. And if you'll just pardon me while I get this going. Go on to my clips. And voila. So here we have a similar presentation to what we were just looking at with those hand-drawn maps, the static maps. It's a different metric, or we're measuring population and number of people per county. And it looks like right across the bottom, we're losing one of the most important features. So I'm going to quit that and code in front of you. Which is really trivial, actually. This is not a big deal. And maybe we can fix that. Yes, OK. So now we've got, I should have turned that off. We've got the legend. So we've got population, and we've got the scale presented down here. It's the color scale. Black represents the median. Essentially, it recedes in the background, and the colors represent the more extreme values. So very high population numbers in LA. LA just seems to be popular, and much lower population numbers in the middle of the mountain regions of the US. And so we've got similar fidelity to what we had in the static presentations, but we can, just with a simple swipe gesture, this was written for the iPad, so you'd be swiping and just kind of tapping and playing with it. We've got access to the next data set, and the next one, and the next one. And this is interesting too. Well, they're all interesting, but one thing that we did to make it immediately intuitive was changed the legend, or changed the scale at the bottom. It's actually even more apparent when we do low birth weight. And here, green represents essentially a bad outcome. There's higher incidences of low birth weight in the south, fewer here, fewer than the median here. And as we toggle through, or we go through these different things, we can go either way. Each one of these represents all the data density that we had on the map. We've got all sorts of different factors we can show. And sometimes,
Green always badness.
Green is always badness, yes. I was looking for that example. Sometimes green is sometimes it represents low, sometimes, or it's lower than the median, sometimes it's higher than the median. But by keeping that mapping to the less desirable outcome, it's very intuitive what you're looking at, where the bad health is. So this is great. We can now swipe through and see a lot of different, essentially with each swipe we get a new map, a new aspect of a new data set. And the comparisons are immediate. You know, I can keep my eye focused on a county in Florida, swipe, and see what this next pattern is in that place in Florida. In addition, we can zoom in. So let's go to Florida. And we can get to that particular county, Hillsborough County, Florida. And I can see actually the numbers for, all the numbers for that county. And so this is in addition to what the map couldn't show, it couldn't show the specific numbers. The static maps could not show. They couldn't show specific numbers for every county. This one we can. In fact, we can show every number for that county. And we can go back out. And actually, I'm going to find Morgan, Johnson, Monroe. That's where I used to live. So hopefully that demonstrates some of the value that you can get from having an interactive graphic. Come on, baby. All right. So, yeah, we can essentially, via the interaction, via very smooth interaction, it enables the comparison. It provides access to all the data that we've got on all these different factors. Now, this is a very straightforward data set. I think the way it comes is essentially in a spreadsheet. And in the columns, it's got the health factors, and in the rows, it's got the county values. And so it's just a two-dimensional data. It's not very tricky at all. If we do a more, not all data is that well organized. A lot of data is more complicated, and you have to impose a lot more structure on it to make sense of it. And so, got an example for you. Buying a car. Not an obvious data problem, right? Buying a car is a very subjective thing. Different people want different things. Some people want, a very efficient car. Some people want, just something big enough to hold their entire family. Some people want performance, the fastest car, et cetera. In that regard, it's very subjective, but each one of these things is measurable, and each one of these decision points can be data-driven, and is data-driven. And when people go to buy a car, if they're looking for fuel efficiency, they look at miles per gallon. If they're looking at performance, they are looking at 0 to 60 speeds, or how fast to go from 0 to 60, and federal crash test ratings for safety, et cetera. So it's a really thick and thorny data problem, because you've got people coming at it from all sorts of different ways. Different things are important to different people. And just quickly walking you through a typical car website, let's just evaluate how well it helps you with all these different ways of thinking about it. And I'm not trying to slam Edmunds.com. They're very typical. They're quite similar. But when we go to Edmunds.com and we're looking for a car, we have two options. We can choose a body type, or we can choose a manufacturer. If I'm really concerned with miles per gallon, fuel efficiency, those options don't help me at all. So we'll just move on. We'll just choose one, choose the wagons. And now there's some more options that are available to me. I've got a price range. But if my price range happens to be around 25, so plus or minus $2,000, I can't do that. I have to go between $15,000 and $35,000, and that's not helping me all that much. Also, it does provide an interface where I can start looking at different factors, which appear to be equally important in this presentation. So there's iPod input and miles per gallon greater than 20. Not exactly what I think about when I'm buying a car. And also, the immediate question is, why 20? Why miles per gallon better than 20? Is that what I can expect from a car these days? So I go through, and it gets a little bit better. I can see, I've got my results based on those criteria. It turns out that I can select more than one, so I can look at hatchbacks and wagons at the same time if I want to. And I get some things right. If I select one of these checkboxes in this long list of checkboxes, the results immediately update. The numbers next to each of those immediately update. So I can see the impact of my decisions quickly. So they get that much going. And they find, so based on these decisions, I get 6 vehicles. But they actually show me 8, because it's paid for by car advertising. So I get this Dodge Journey and the Volkswagen Jetta dumped in my results, even though I have no interest in them. Okay, I'm at a comparison page where I can hopefully look at a little bit of a splash page to kind of say, well, do I want this one? Which do I want to explore more? And the data they give me to explore more is they give me the miles per gallon, they give me a consumer review, the make and model, and the price. But if I'm concerned with safety, if I'm concerned with performance, it's not here. And I have to dive a lot deeper to get that. I choose the Subaru, and it takes me to a page that does absolutely nothing for me. But if I click through, then I get to a lot more text. And probably all the details I'm interested in are in the text. But processing text, reading text, extracting the data from text takes a long time. And so how does this map to how we want to explore cars? Well, if you're the sort of person that's really concerned with the make and with the body type, it's not a terrible start. But if your path to looking for a car is different, you're going to have a hard time. The richest information is only after you've gone through a lot of it. The information that's at that deepest level is fairly unstructured. It's hard to extract what you're really, find the things that you really want out of it. And the comparisons, quite limited. That's it, and thank you for your time. And that's the Fathom team as of last summer, right there. So, oh, we do have questions. Bill, you're right there.
So when we were looking at the stacks of the Union,
Yes. Do you want me to pull it up? or-
no.
Okay.
Color is a very useful thing for presenting data.
Yeah.
But the Consumer Reports people took into account you might be colorblind or you might not be able to see the colors, so they have the dots. And
Yeah, the Harvey balls have the different shapes.
How do you make sure that your visual displays are useful to a colorblind person?
So that's an excellent question. Judge, I think your voice, everyone heard the question. How do we make sure that these things are actually useful for colorblind people? And that's a decision we make with every piece. That was a very consumer-oriented piece, and it wasn't, so it wouldn't be useful for necessarily. I think that color scale, it's avoids the red-green color blindness because it's a blue-green scale for the most part. But that's a tough call. I don't have a set answer to that because color is such a rich, informative thing. So if it were an application where we did need to support a known community that included color blindness, then we take that into account. I think that's the best answer.
Hi, my name is Christina.
Yes.
I'm with MadPow, and I have one question on your stats of the Union.
Mm-hmm.
You had one specific data point you were looking at, like infant mortality rate.
Okay.
But you had two colors. And the
Yes.
two colors and then two gradients of that color. Can you
Actually-
talk a little bit about that?
Yes.
And I might then have a counter
A
question or comment.
follow-up question? Okay. Let me see if I can pull that up for you. Let's, so in general, the color, the legend at the bottom there. So let's go to infant mortality rate. I think that birth weights or.
So all of them have like life expectancy, but then two colors.
Yes.
So if you can talk a little bit about why you did that.
So essentially, black represents the median. So it's the kind of least informative area. And so we wanted to show essentially the two colors, the green and the blue, and they represent kind of the distance from the median. And that way, it allows a kind of, with equal intensity, you can see the highs and the lows. I think that's the best answer. Does that kind of answer your question?
Yeah, follow up later.
Okay.
Can I ask?
Yeah.
Since you're on this, hi, David Rose. It seems like the Tufty Napoleon's March that we have all come to know and love tries to answer the question why, and even though it's a political question here, just this data visualization just begs the question of why is infant mortality different in the South? Why this? Why? And so as a data visualization person, don't you crave to be able to answer that question as well?
Absolutely.
So how could you have answered that in this project?
In this project, we couldn't, just simply because the data was sort of part of what was given to us to work with. And so the data as to what's causing infant mortality rates, what's causing all these different health factors is, I don't know where that data exists. And that is part of the work is kind of finding the good data.
Does anybody else in the room have an idea of how to answer the why question for the center visualization?
Mike is coming. I think there's a difference between data visualization and information visualization, and there's kind of a line to walk often. So this is all, from my perspective, has been data visualization, where you take facts and data and you present them in a way that's easily digestible, as opposed to information visualization, which answers the question why. So I mean, I'd like to hear your thoughts on if you agree on that, or.
It's not I agree that that different applications will address different questions, like presenting the data definitely, I think part of this piece actually, to kind of address both of your questions, was to get people to ask why. At the same time, it wasn't the scope to be able to answer it, simply because, well, part of the reality is that it's a client project, and we had a scope and we had a schedule and we had to meet it. And I think at the same time, like if that data were available and convenient, we'd totally love to do it. But it's the scope of the data and what the data will support is definitely part of the issue. But at the same time, if the why is there, I would definitely include it. And I don't know that I would make the distinction between information, visualization, and data, but it's probably worthwhile. But someone's got the mic right here, and he's dying to ask a question.
Yeah. So I think that I don't think that you can. I don't think that you really would be. It would be really challenging to put the why into it, because I think there's a lot of debate and there's so many different variables at play. And one of the things that I was going to ask was actually related to the fact that there are multiple variables. Depending on which variables you end up visualizing, you're going to get a different picture, and therefore you have to sort of ask yourself, what is the story that I'm trying to tell? What is the data that I'm trying to represent? Because it's very easy to either on purpose or in error create a false impression by what data is visualized.
Actually, that raises an excellent point. And the backstory to this piece is, or one of the backstories to this piece, is that the Health and Human Services released this data, and there's a website where you can go and find it, and it's just very painful. It's find this county, find this factor, I go to the page, I can read it, and it's very hard to digest. So part of the scope was take that same information and make it instantly accessible, get it in front of people, and I think there have been 70,000 downloads from the App Store of this, so people just kind of playing with the data and looking at it, and which they probably wouldn't, truth be told, I don't know how deeply they're looking at it. I don't know how much, I don't know if they're like writing their Congress representatives and saying, hey, but it's getting in front of people, and that was the primary goal of the piece, was just to get this data in front of more people. Yeah, your hand went up so fast. Yeah, pre-attentive variables.
I just had a. So my question is, well, it's actually more of a statement. Mm-hmm. So when you look at the data, there's two things. Like to your point from MadPow, we're getting everybody there. They get the iPad apps. They look at this data. And they're like, oh, this is a great visualization. But it's playing with it and then taking an app, some of these things like corporate wants to do, and put them into everyday use when you have to use it. It's fun when you just like your Fortune 500. It's just die. No, maybe not. The Fortune 500 one, you can scan it, and it's fun if you're just looking at it to get data. But if you had to use that every day to get your data, that would be painful.
Absolutely.
So it's how you use it. Absolutely. As well.
And
it's a big piece.
Yes, I couldn't agree with you more. Like, audience is critical, and these applications are meant to kind of get people interested, have them play with it. If we were doing a desktop application for a financial analyst that needed to look at Fortune 500 data, that is not the application we would give them.
And the second point was just correlations, because when you look at your data-dense population, one of them was cancer rates. Well, cancer rates in LA and Boston Northeast, well, that's wonderful. And the next thing I want to see is okay, well, those are where the big medical centers are, so is that why they're finding cancer more?
Yeah, exactly.
Aaron, I just want to point out that visualizing the data is one of the ways you know how to ask why. That you don't often, until you visualize it, it's not obvious that there's a why question to be asked.
Yeah, that's an excellent point as well, which we hope to do with this one.
Well, I was just going to point out that Tufte, one of the things that Tufte has in his book is showing, I think it was cholera, showing the incidence of cholera in London, and showing that they were clustered around certain wells.
There's a handle on a pump.
So I mean, the question of information versus data, you sort of can't ask why.
Yeah.
That requires human intelligence rather than
Though theoretically, if you had the data, but I can't answer why. No, yeah, if and it depends on what the data will support. You know, you can't read too much into the data or not. So, yeah.
Mark will still be here.
Yeah, I'm happy to answer any questions.
But it's time to break for dessert.
Yes, we'll have dessert over in the kitchen.